Can artificial intelligence really help forecast a hurricane? I think we're going to find out a lot during the 2025 hurricane season. Exciting stuff with artificial intelligence, and a very exciting announcement from Google that they have now entered the weather forecasting game here and created their own AI model. We're going to go over some examples of how it did during testing over the last two hurricane seasons coming up in a couple of minutes. But at first, want to talk about how this thing actually works, how AI models work in general, and how they differ from the traditional math and physics based models that we use all the time and that we show you on TV. So, first and foremost, here's how it works. It still needs weather data. So we need those observations. It's critical to be ingested into this AI model. They're a little different than their traditional models. We'll get to that in just one second. But by using the observations that are being taken from around the world that would go into the European model, it's going to use past weather events, see how they're similar, and then come up with a forecast based on past observations that it computes. Now, where it's different than a traditional model, it's going to take all of those observations from around the world. It's going to be thrown into these giant supercomputers, and then those numbers are going to be crunched with physics equations and intense math equations to come up with a solution that way. So those are the traditional. The AI is using the past to kind of predict what a current storm or a storm in question could potentially do. Now, in testing, it has done very well. I think the one thing when looking back at some of this so far as this now just burst onto the scene is Hurricane Otis. Now, let me give you some backstory on Otis. This was an Eastern Pacific storm back in 2023. It was expected to just fizzle out. If you know this storm, you know it made landfall near Acapulco near as a Category 5 hurricane. Major forecast bust on that storm. The Google AI model did a much better job than the others. It was not perfect by any means, but it did showcase high end potential. So let's look at this. Now, this black line on your screen here, this is the observation. The blue line on your screen is what the Google AI model predicted during its test run in 2023. So you see, it still had this hook rather than going straight. So a little bit of an error there. What was the impressive part to me, anyway, was the intensity. So we're looking up in this box now, and what you see here, this black line represents the intensity. That is the observed. That's what actually happened. This line here going across marks Category 5 status. The blue, getting too many lines on here. The blue here represents the tip top of those 50 members or those 50 solutions that the AI model kind of spit out there. The blue represents dark blue down here represents the mean. So the mean was still way under, but there were several different solutions that suggested at least a run that this thing had high end potential. This line here going across represents major hurricane status. And let me clean this up again to show you that there were a few of them anyway. And I'll turn on all of those lines. And that's the cool thing you can play with. And I have again the link in there. There were the ensembles. Let me draw that major hurricane line again. And you see there were a few squiggly lines above that. Now, how that would have helped in real time, nobody knows because this was not operational. It wasn't. It was in testing, but it at least piques your interest. Like, hey, there's something going on there that would make this AI model believe that there is high end potential with this storm, and we need to investigate that further. Same thing with the pressure. The lower the pressure, stronger the storm. There's the observation, and a few of them getting it on the stronger side again to reach major hurricane status. So again, it is not perfect. No model is. Guidance, not gospel. It's a tool in the toolbox. And this is going to be a very powerful tool in the toolbox because the one thing about it, I mentioned past to predict the future. We use analogs a lot. Okay, high pressure over here. We have a dip in the jet stream over here. These AI models are going to be much, much faster than a human to be like, okay, back in 92, we had high pressure here that steered Andrew into Florida. AI is going to help to bring up all of those different weather charts and then compile that into those 50 scenarios, then it's up to the forecaster to look at the physics-based models and AI and all of that stuff to be like, okay, now we think this is what's going to happen. So again, a very powerful tool in a toolbox. AI is very fast. Anybody that's used ChatGPT or any of the other stuff knows how fast and how incredible these things are. Okay, so that was Otis. I want to show you some of the ones from last year. This was Helene. We know it hit Florida. It's really cool, this interface. It plays out kind of the movie to kind of show you where Google was in the blue versus the observed line in the black, and it'll do its loop the loop again. And you see here, again, running side by side in terms of the intensity. Sometimes the Google AI was a little too strong, and then it was a little too weak at landfall. Still, you see how closely they are together in both track and then intensity and those boxes on the right. It did a very good job with Helene. Helene was well forecast with the physics-based models too, but and it was a very good forecast from the official forecast from the Hurricane Center, as was Milton. Now the high end, that was crazy. Again, Milton got super strong, a sub 900 millibar storm. That is a very strong storm. Again, in category 5 a couple of times. This is where it still needs a little help. Now, Milton was a rare storm in the sense it started in the extreme southern Gulf and then worked its way east. Only a handful of times in the past 100 plus years has a storm track like that happened. Now, it did pretty well. The mean of those 50 ensembles, we'll show them there again. There's all of the 50 solutions that it spit out. The mean, taking that off, was right there, and it was very close. We'll take you right into where it made landfall. Again, the black is the observed of what actually happened closer to Sarasota. It argued for a few miles up the coast. Still very, very close, and that is extremely helpful for evacuations if there's a forecast that far out. That is that spot on. The one spot where this did struggle, the intensity here. There's the high end Cat 5. Its highest ensemble member was right there. Still a major hurricane, but I mean, that thing, if you remember the satellite of Milton, was cranking. So it missed the super high end potential of Milton. But again, it was a rare storm. And when you're talking about something looking at past events to go for a future event or a future outcome of a current storm, it may struggle in that part. That's going to be the interesting thing to watch as these AI models continue to come on scene. Still, though, if you used AI, you know there's a learning capability, so it's going to learn. It can maybe come up with new solutions as well, even if it's not in the database. So it's a really exciting time for forecasting. Obviously, we need these models to kind of help bring a solution to the forefront. And it's still going to be the human forecaster's job to find out, okay, is this working? Is this not working? Do we need the physics base in this solution, in this scenario, more than the AI, or vice versa? So there's a lot of room still that the human forecaster needs to dissect. The AI model from Google, the Euro AI that started to come out really last year, and then all of the physics based models that we have, they are just big, big tools in a toolbox to help humans forecast the weather, specifically tropical systems, a little bit better.